All right, so number 5, example number 5 on your verifying notes, 5.2 verifying notes. The first thing we're going to do, first of all, you should have your identities right next to you. But we're going to do our little T-chart. All right, do your little T-chart, and we're going to figure out which side looks more difficult. The right-hand side. The right-hand side is more difficult because we have a fraction. And if you look in that fraction, guys, there's 2 terms. It's not just a monomial, just one term where you just cross stuff out. When you have a question that starts off like this, right? Let's look. We want to simplify the right-hand side first. Okay, fine. I see 1 minus sign. Is that one of our Pythagorean identities? No. I had people first period, they just changed 1 minus sign to cosine squared. You guys can't just create your own math. It has to be squared in order for it to be a Pythagorean identity. So when you start off with a problem that has 2 terms in a denominator, see how it's 1 minus? We have to somehow create an identity to make this a little easier for us. So if I was going to create a Pythagorean identity, what would I multiply the denominator by? How did we do that? We did an example like that before. Remember, we tried to get i's out of a denominator. What did we multiply by?
1 minus 7.
Not 1 minus, 1 plus. You're going to multiply by the conjugate. And the reason we do that is to create an identity. Guys, what you do to the bottom, you do where? To the top, okay? So let's do that. Leave the numerator alone. Don't worry about multiplying it together right now. You don't need to. You could just leave it. Now, if we FOIL the bottom, what's 1 times 1? 1. What's 1 times sine? So plus sine. What's negative sine times 1? Minus sine. And then what's negative sine and positive sine? Minus sine squared, right? All right, so what do you notice happens in the denominator? The signs cancel. You're left with 1 minus sine squared. What is 1 minus sine squared the same as? Cosine squared. So what we've done, guys, just by multiplying by the conjugate, you have taken away that binomial that was in the denominator, and you've created that Pythagorean identity, so now it's just a monomial. When you have a monomial under there, you can split stuff up, you can break, all that good stuff. But what do you notice? What can we do now? We don't multiply yet. You can cancel out a cosine, right? There's 1 on top here, and there's 2 on the bottom, so we can take one of them out. Now you're kind of like, okay, wait, what do we do? Remember, when all else fails, we turn everything to sine and cosines. But we're already in sine and cosine on the right-hand side. Look at the left-hand side. Let that guide you a little bit. Now that we have 1 monomial in the denominator, think algebraically, guys. Can I split that green fraction up? Yes. I could say 7 over 4 plus 3x over 4, right? Can I do the same thing with my blue fraction? Yeah. I can rewrite this as 1 over cosine plus sine over cosine. Is that allowed? Yeah, you can do that.
Why is there a cosine in the denominator?
Say it again.
Why is there a cosine in the denominator?
Because we had 1 minus sine squared,
Oh, okay.
and that was cosine squared, and then it canceled. All right, guys, is there another way? Yeah.
What happened to the square?
There was 1 here, and I canceled that 1 there. Now look at where we're trying to go on the left-hand side, and look at where we are on the right-hand side. Can I rewrite 1 over cosine? Can I simplify that? Secant. Can I simplify sine over cosine?
Yeah.
To what? Tangent. Which is exactly where we were trying to go. It's always easier when the hardest part is the first step. And then once you kind of figure out, okay, where do I go? Then it all just kind of falls into place. I know. We just got to keep practicing. This next one is not great. Number 6 is not great. I know it's not great. Number 9 on your homework was not great. I know it's not great.
And number 10.
I don't think it was horrible.
Oh, okay.
All right, let's start. Let's go through the same thing we just did. Which side looks harder?
The left.
Why is the left harder?
They're squared.
Because the denominator has the 1 and a trig function, and it's not squared. That is not a Pythagorean identity. You can't just change that into something. So what are we going to have to multiply by?
Wait.
1 minus.
Same thing we did over here, guys. Same thing. What are we going to multiply by?
1 minus cosecant.
Okay, 1 minus cosecant. 1 minus cosecant. This is a hard problem. I understand that. Just relax. It's going to cause us to think a little bit. So again, just like we did the last problem, don't worry about multiplying the numerators or anything yet. Just leave it. I'm going to put cotangent in front. And then my 1 minus cosecant. So let's work on the bottom. Let's FOIL. 1 times 1 is?
1.
1 times cosecant plus cosecant. Negative cosecant of 1 is minus cosecant. Negative cosecant and positive cosecant is minus cosecant squared. All right, what happens? The cosecants cancel, so I'm left with 1 minus cosecant squared theta, right? That's where we are here. All right, where should we look? I have 1 minus something, and it's squared. Where should my eyes go?
To the chart.
To the chart. To which part of the chart? The Pythagorean identities. Is there a Pythagorean identity that involves cosecant squared and a 1?
Yes.
What is it? Okay, so cotangent squared equals what? Cosecant squared, what? Minus 1. All right, are those two exactly the same?
No.
No. But can I algebraically manipulate it so I have 1 minus cosecant? What could I do? Multiply the whole thing by negative? All right, so if I multiply this whole thing by negative 1, what happens?
Negative both.
Negative cotangent,
Negative.
negative cosecant, and a positive 1, right? Absolutely, you could do that. You could also add and subtract, move from one side to the left-hand side, but that's good that you guys just recognize that 1 minus cosecant squared is the same thing as what? What did you just tell me? It's not cotangent squared, it's what?
Negative both.
Negative cotangent squared. Good. All right, we're not there yet, but we're getting there. We can still, now we can simplify a little bit, can't we?
Yeah.
What can we cross out?
Cotangent.
The cotangents. Does the negative go anywhere? No, it's still negative, and then 1 minus cosecant. Can I rewrite that so that negative's just not outside the parenthesis?
Yeah.
What would it be?
Negative 1 plus cosecant.
Negative 1 plus cosecant theta. All right, what's another way I could rewrite that just so the trig functions first?
Cosecant theta.
Yep. All right. All three of those things are the same. All three of those things are the same. So now I'm looking over here, and I'm like, well, that doesn't look the same like all the other ones have. Right? 90% of the time, you can focus on just one side, and it'll work out nice and pretty. Sometimes, rarely, that's not the case, and that's okay. Do you guys notice, I just want you to look, do you notice anything in common that the left-hand side and the right-hand side has? They both have a 1, good. What else do you notice? What about cosecant and sine? Are they reciprocals of each other? So that means you're on the right track. You guys are on the right track. So let's look over here. You could stay over here and rework this a little more, but let's look over here for a second and see if this will help. I have a monomial in my denominator, right? 3 plus 7x over 4. Can I split that up?
Yeah.
What would I split it up to be?
1 over sine
1 over sine
theta.
theta
Minus
minus sine over sine, right? Which Marcella just said was 1. Is there another way I could write 1 over sine?
cosecant.
Is there another way I could write sine over sine? Are those two now the same things?
And if you wanted to, you
Oh,
could've-
shoot. Oh.
Or what could you have done over here?
you could've kept going.
You could have kept going and changed it to 1 minus sine theta over sine theta. But you have to, there's not a particular way that you guys can every single time do the same thing. No. That's why these are difficult. Some are harder than others. I understand that. But each step, check to see, am I on the right track? When you guys got here, you guys agreed with me. Oh, wait a second. I see a relationship. Sine and cosecant are reciprocals. One of them had a -1. The other one had a minus. You know, like you can kind of start to see, yes, I'm on the right track, or no, this is not great. All right. I know these are not awesome. I understand that. All right, let's go to web assign. Pull up your web assigns. All right, let's look at something like number 6. First of all, number 6 is not bad. Why is number 6 not that bad? Okay, there's lots of squares. What does it not have? Plus and minuses. We don't have anything plus and minus attached. It's really pretty basic, and you're just kind of simplifying. So I'm going to keep 2 sine squared theta in the numerator. And what am I going to change tangent to? Sine squared over cosine squared. Why did I start on the left-hand side? Because it's the more complicated one. I should have said that at the beginning. Sorry. So now, do you guys agree with me? I have a fraction equal to, or divided by a fraction? Okay. So we have 2 sine squared. Keep, what is it? Stay. Keep, change, flip. So change, and when I flip, what does this become? Cosine over sine. What do y'all notice? The signs cancel, and you're left with what? 2 cosine squared theta, which is the same thing, right? Easy enough. Let's look at 7. It's not that bad, I promise.
That was terrible.
It's not going to be, because we're going to do the same thing we've been doing, all right? Which side's harder?
The right.
For sure the left.
No, like the right side on the left.
Well, there's only one side of the equal sign we're looking at. We're looking at the left-hand side of the equal sign. All right, so again, how do I tell you guys to keep thinking? Algebraically. So look, 1/2 plus 1/3. What would you do? Find a common denominator. All we're doing here is adding 2 fractions. So between cosine theta and 1 plus sine theta, you would just take both of those denominators and multiply them together. We've done this a million times. Now we figure out what the first fraction has, what it's missing, what the second fraction has, what it's missing. My first fraction has a cosine in the denominator. What is it missing? 1 plus sine, right? So if I have 1 plus sine in the denominator, then I multiply the top. Agreed? Okay. My second fraction has the 1 plus sine. What's it missing? Okay. Nothing new. So let's FOIL. What's 1 times 1? 1. What's 1 times sine? Plus sine. What's sine times 1? Plus sine. What's sine times sine? All right, this is a little different because usually you guys are like, oh, good, the signs cancel out. 1 minus sine squared is cosine. We're good. It didn't happen here, but no big deal. I have a plus sign. What's cosine times cosine? Cosine squared. Focusing on the numerator. Did anybody notice anything?
You could add in signs.
I can add these 2 signs together. Agreed. So this would give me 2 sine of theta. Anybody else notice anything about the numerator?
You could make that a combination.
Sine squared plus cosine squared equals what number?
1. Wait, how do you know that?
It's a Pythagorean identity.
Oh.
Does anybody notice anything I can combine?
1 and 1, 2.
1 and 1 are 2. Okay, agreed?
Are we gonna have the chart on
Yep.
the desk?
Yep. Okay? We're good? All right, now we're trying to get over here to secant. All right, we're getting there. Anybody notice anything about the numerator? Do they have anything in common? Because we're thinking algebraically.
What's the other numerator? What's like the other one that we're trying to get to?
2 secant. Look at my numerator. What do they have in common? They both have a 2, don't they? So can I factor it out? 2, and then I have sine theta plus 1 over cosine theta, 1 plus sine theta. Think algebraically. If that said 2x plus 2, you guys would tell me, oh, you just took a 2 out. Same thing. Do we notice anything? Can I cross out what? Yep. Is 1 plus sine theta the same as sine theta plus 1?
Yes.
Sure is. And then what's another way that I could write 2 over cosine theta? What's 1 over cosine the same as? Secant. So this is 2 secant theta equals 2 secant theta. But we started off the same way we started off the last 2 examples, with that 1 plus something in the denominator, but it wasn't squared. So you either multiply by the conjugate if there's only one denominator, or you combine them if there's 2. Just like you would algebraically. Okay? Stay with me. All right, this one looks difficult, and it's really not. Which side looks harder? The left, for sure. Where should your eyes go first on your trig sheet? Okay, left side. Okay, why is the secant squared minus 1? It's probably a what? A Pythagorean identity. Probably. Look and see if it is. It's squared, and it's attached to a plus or minus 1. Does secant squared theta minus 1 equal something? Tangent squared. At this point, some of you go, oh, well, cotangent and tangent are reciprocals of each other, and they cross out. Some of you are like, what? Which is fine. We get to this point, and I'm not sure what else to do. So what are the 2 most basic trig functions? Cosine and sine. So what does cotangent squared become? Cosine squared over sine squared. Good. What does tangent become? Sine squared over cosine squared. What happens here, guys? They cancel, and you get 8 equals 8. You have to run through. You can't just look at it and go, you have to say, okay, do I have a trig function that's squared that's attached to a plus or minus 1? Do I have a denominator that has a plus or minus 1 in it, but it's not squared? I got to get rid of it, something like that. All right, let's look at 9. There is a shorter way to do 9, but I'm not going to do it because it's not how you guys would think. Some of you are like, I wouldn't even think to do it the way you did it this way. But if we're going in the direction that we've been doing all of these, that's the direction I'm taking right now. Okay, which side looks, yeah.
If you really wanted to, you could go backwards from this side.
Yep. But what, first of all, somebody last period kept arguing with me. 1 minus cosine is sine squared. No, it's not. If the cosine was squared, then we'd be all right, but we're not. But which side looks more difficult? The left, for sure. I have that denominator that has a 1 minus or 1 plus, but it's not squared. So what have we done in all the examples today to get rid of that? You multiplied by the what? By the conjugate. Good. All right, so 1 plus. 1 plus. Do you guys agree with me that I can take an 8 out in front? Because they both have, right? So I'm just going to rewrite it like this. 1 plus cosine. And then secant minus 1. Agreed? Okay, so on the bottom, when we FOIL, 1 times 1 is 1, right? 1 times negative cosine is minus. Cosine of 1 is plus. And then cosine and negative cosine is negative cosine squared. So we've created the identity. What happens to your cosine squareds? They cancel. What is 1 minus cosine squared equal to? Yep, sine squared. So now we have a sine squared on the bottom. Now, what I want you guys to pay attention to. Notice what we have, right? We got the 8. But look at the 2 parentheses that you have to multiply together. Do you notice anything about them? They are opposites. Are they reciprocals of each other? Cosine and secant are reciprocals, no? And I have a positive one and a negative one. Means you're on the right track. You could, at this point, cross those out. Some of you are like, I would not even think or know how to do that. That's fine. I'm just letting you know that that's what, and then you'd have 8 over sine squared, which is the same as secant, but let me show you why. Okay, in order to FOIL these, you could FOIL it like it is and then do the conversion. I'm going to go ahead and convert now. I'm going to stick this 8 out in front. And I'm going to have 1 plus cosine. What's another way that I could write secant? 1 over cosine. Okay. And then I have minus 1. Agreed? Okay. So I got the 8. If we FOIL this, what's 1 times 1 over cosine? 1 over cosine, right? Okay. What is 1 times negative 1? What is cosine times 1 over cosine? Cosine over what? So 1, good. And then what's 1 times negative 1, sorry, times cosine? Minus cosine. Agreed? Okay, you guys are doing good. My sine squared's still there. What's cosine over cosine equal? So I have a negative 1 and a positive 1. What's going to happen? They cancel. Good. So I'm rewriting this a lot, I know, but just so you guys can see. So here I'm left with 1 over cosine minus cosine over what? Is everyone still with me? Okay, look at those two fractions. If I'm going to subtract them, they have to have a what? So I need this to be cosine, right? So I'd have to multiply the top by cosine. I know. You guys are like, seriously? Where? Here? That says sine squared theta. Guys, what is 1 minus cosine equal? 1 minus cosine squared.
Sine squared.
This equals sine squared. So we have 8. Guys still with me? Cosine squared theta. No, I didn't mean to write that. I was looking at what's, sorry, you're right. If I keep change flip. Yep.
If the numerator.
Good question. If the numerator is squared but the denominator is not, cannot change it. That's okay. So guys, look, if I keep change flip, stay change, whatever Susie says. What happens to your sine squareds? They cancel. So you're left with 8 over cosine, which is the same as secant. Now, most of you are sitting here going, you got to be kidding me, right? I've told you, many of yours should not be this many steps. There is a shorter way to it. The way that WebAssign did it was at this point, they changed these. Wrong problem. Sorry. They changed this to 1 over secant and then went that way with it. We haven't done any where we started off doing that. Every single one we've done, we started off just going with, okay, multiply by the conjugate, stuff like that. All right, let's go to number 10, and then I'll let you guys start. Excuse me, on the wrap up. Okay, we're going to start per usual. We're going to say, okay, here we go. Which side looks more difficult? The left-hand side, okay. What is great about this problem? It doesn't have what? No fractions. So that means we can handle this. If we don't have fractions, then we're going to go ahead and say, all right, we're going to convert as much as we can. Do you guys agree with me that both of them have an 8, so I can just bring it out in front so I don't have to worry about it? Yeah? Okay, so then I'm left with cosine theta plus sine theta tangent theta. All right, nothing squared. We don't have anything attached to a plus or minus 1, so let's just change everything to sines and cosines. So I still have my 8. I have cosine theta over 1 plus sine theta over 1 times sine over what? Okay. Everybody with me? So let's just simplify it a little bit. I have cosine still over 1 plus what? Sine squared over cosine. Do I have two fractions that I'm adding together that seem to have different denominators? Okay, so if you're going to get a common denominator, what's your common denominator going to be between 1 and cosine? Cosine, good. First fraction needs a cosine on the bottom, yeah? So that means I need one on the top. What is cosine times cosine? Cosine squared. My second fraction has the cosine. Does it need another one?
No.
No, so I have sine squared. I like that confidence. Does anybody notice anything about your numerator? How do you know it equals 1? Because it's one of those Pythagorean theorems. So I have 8 times 1 over cosine. What's another way, guys, I can write 1 over cosine? So 8 secant theta, which is exactly where we were trying to go. Okay. All right, you guys have an assignment. I think I called it 5152 wrap up or quiz practice or something. I have it due Tuesday morning. You should come in here with a majority of it done or problems highlighted that says, hey, I need help with this. I'm going to go over as many of the problems tomorrow as I can in class, but I probably won't have time to do all of them. I will post all of the answers though. But go ahead and get started. Look at them. Start on the ones you know how to do, the ones you don't know how to do. Put a star next to them. We'll go over them tomorrow.